What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. Today we're going to be continuing our discussion on SN2, SN1, E2, and E1 formation of products, okay? So I went ahead and put an example on the board. I want you guys to give it a try. Go ahead and examine the substrate, look at our nucleophile, look at our solvent, and try to determine what our major product is going to be, all right? So if we begin, we have to analyze our substrate. So we need to determine whether it's going to be hindered or unhindered and whether it's primary, secondary, tertiary. Whenever we do that, we're analyzing the carbon that contains our leaving group. So here I see a good leaving group. That's the first thing we need. We're going to need a good leaving group in order to be able to carry out any kind of reaction. So, and this carbon has a carbon next door and a second carbon next door. So since there are two carbons next to our central carbon that we're examining, this is going to be called secondary. Okay, now remember, you're going to want to refer back to that table that I went ahead and drew out for us in the previous video. And you're going to look in the row and see this is secondary, and then examine the nucleophile to determine what type of reaction we might get. Okay, so if this is secondary and I have an NaOC double bond O CH3, well, I know that this is just a spectator ion that's positively charged. That means my oxygen here is going to be negatively charged. This is going to be serving as our nucleophile. And DMSO, what do you guys think DMSO is doing? Well, DMSO is our solvent. And in this case, it's going to be a polar aprotic solvent. Now, what is that going to do? Well, if we do an SN2 reaction, in order to get high yield, we would expect to see DMSO, or a polar aprotic solvent, in our medium, right? Because we wouldn't want any kind of hydrogen bonding to occur if we had a polar protic solvent. Because then the polar solvent, the polar protic solvent, could interact with our nucleophile and we wouldn't expect to see high yield. So I'm seeing secondary. I'm seeing a good nucleophile. Good nucleophile. I'm expecting to see SN2 conditions, okay? This is an OR functional group, all right? It's relatively small to this OC double bond O CH3. So what that means is I'm going to have this occur in one step, where this guy comes and does a backside attack and kicks out our leaving group. So it leaves us with an inversion of the stereochem. So now our new product is going to have this group coming at us. All right. There's our product. And that polar aprotic solvent helped our secondary, right? Because we normally expect primary to see an SN2 type reaction. Once it's secondary, it's kind of in the middle, whether it can go SN2 E2 or SN1 E1. So the solvent here is going to help us really push the reaction in order to get our favorable SN2 product. All right, so that's it for this video. Stick around for more examples soon. All right, thanks guys.